All right, good morning, everyone. Thank you for your patience. We appreciate it. We're going to get started with day two of the Perimeter Air Monitoring Technical Guidance Training. Next slide, please. My name is Alyssa Ambacher, and I'm here with Ryan Callahan, and we're from the CSRR Training Committee, and we will be moderating today's training. Next slide, please. If you're here for continuing education credits, this training has been approved for 2.5 technical CECs. In order to be eligible for those CECs, you need to be logged in for the entire session, and you need to answer all the poll questions that are randomly inserted into the presentation. Make sure when the poll question comes up, you answer it in the poll window and not in the questions window. So make sure you answer the poll question in the poll window and not in the chat or question box. Next slide, please. All right, so the board has approved the credits for this course already. So when the course is done, we will send a list of eligible participants to the LSRPA, and then they will reach out to you with information on how to access your certificate. And you have to pay the LSRPA a processing fee of $25 in order to get your certificate. Next slide, please.
Good morning, everybody. So this is an example of a test poll that we have here. We're going to have these frequently throughout today's presentation, so that way we can make sure that you guys are up to date with all of your knowledge and you are paying attention today. These will be presented and you just select whatever answer is correct and you'll get credit for being at today's training. Next slide, please. At the end of the presentation, please do not forget to fill out our SurveyMonkey. It is a course evaluation. Your feedback lets us know how good we're doing and some things that we can improve on. Next slide, please.
All right, so if you want to communicate with us, there is a question and chat function. We have been told that on the attendees end, that is now merged into one function. So if you want to ask us a question or let us know about any technical issues that you have, you can use that chat/question function. Please make sure that if you're going to ask a question, it's not site-specific and it's more general. It should be relatively short because we will be reading them out loud, and sometimes if the question's too long, it can get a little bit confusing for the people trying to answer the question. And if the question isn't answered during the presentation, you'll be receiving a follow-up email from us with that information. And then we also just wanted to point out that if you switch devices while you're on this training, you might not be able to log in again. So we encourage you to stay logged in on whatever device that you first logged in on. Next slide, please. All right, so your job at this training is to participate, ask questions, complete the polls, especially if you want CECs, and provide feedback in the SurveyMonkey. Next slide, please.
Good morning, everyone. Brian Musser here, Penn Jersey Environmental, on behalf of the LSRPA. Next slide, please. Just a couple quick things this morning. We'd first like to thank our diamond partners, as you can see listed below. Next slide, please. Our gold partners. Next slide, please. Our silver partners. Next slide, please. A few upcoming courses and events we have going on. Our Aspiring Professionals series, three classes, sessions coming up January 25th, February 1st, and February 15th, dealing with different understanding risks and liabilities. February 13th, virtual regulatory roundtable, dealing with the issues we find when we're dealing with off-site access. February 15th, Site Remediation Professional Licensing Board rule update, important updates that have come through recently. And February 29th, we also have a Field Sampling Procedures Manual training. Next slide, please. As we get into March, another regulatory roundtable, unmanned aerial systems. On March 19th, we have a remedial funding source and financial assurance training. Any updates there? And on April 16th and 18th, we have 8-hour refresher training with Dave Sweeney for anyone who needs that training. Next slide, please. April of this year, we're hosting our annual conference, the Hyatt Regency in New Brunswick. We invite everyone to attend. Sign up is open, so please sign up if you plan on attending. Next slide, please. Excuse me. Big hit in the past couple of years, Battle of the Band, along with the Society of Women Environmental Professionals and BCONE. That's May 9th. It's a good scholarship fundraiser for everybody. Good time had by all. Next slide, please. Follow us on social media, Facebook, X, LinkedIn, wherever you get your information. We like to give information on a number of different locations, platforms. Next slide, please. And if you haven't renewed your registration or your membership for the new year, please go ahead and do so. I know it's early January or end of January now, but if you wouldn't mind, please go on and get involved. Next slide, please. If you're not a member, 300 plus people on here. If you're not a member, please feel free to join. We're always looking for new ideas, help on committees. It's a great way to network and kind of know what's going on with our industry. Next slide, please. Thank you very much.
Okay, so up next, we're going to have Erica Snyder presenting. She's going to be presenting steps 6 and 7. So Erica, you can take it away now.
Hello, everyone. Welcome back this morning. I hope everybody had a good evening and are refreshed and are excited to learn all about perimeter air monitoring again today. Again, my name is Erica Snyder. I work for the New Jersey Department of Environmental Protection in the Contaminated Site Remediation and Redevelopment Program. I've been with the department for about 20 years. The first 12 years, I was in the air program as a risk assessor for air toxics. And then I decided I wanted to mix things up and play in the dirt. And I've been with contaminated site remediation and redevelopment ever since. Prior to that, I also have some experience as an analytical chemist for a specialty gas mixtures company. I'm going to start off today providing an overview of the training that occurred yesterday, just to give everybody a refresher. And then from there, I'll provide a brief overview of the agenda topics that we're going to go over, and then we'll take things off from there. Next slide. All right, so to start off, I'm expecting most of you are experts on this after yesterday's talk, but I just wanted to cover it again. What is perimeter air monitoring? Perimeter air monitoring, also referred to as PAM, is a combination of tools, processes, and actions that are designed to mitigate the off-site migration of air contaminants associated with remedial activities in order to protect the health of off-site receptors. There are several main elements to PAM, and those include the collection and evaluation of both real-time and analytical air data. This data is reviewed to determine if off-site receptor exposures are maintained at levels protective of human health. Those levels that we went over yesterday are health-based threshold values, and then for real-time monitoring, they are response levels. The second main element of PAM is to proactively reduce potential impacts to human health before they occur. We use our response levels with real-time monitoring to assess what air concentrations are occurring and potentially migrating off of the site in order to determine whether we need to have additional actions to reduce emissions. And lastly, the purpose of perimeter monitoring is to be able to document that you were able to protect off-site receptors and that your PAM program was effective. Next slide. Joanne Held yesterday went over the applicability requirements for perimeter monitoring. PAM is required by the technical requirements for site remediation at 5.5B7. And there are several applicability triggers that are detailed in the PAM guidance for when PAM is required at the site. Those involve remedial activities with a project duration greater than 20 working days within a 30-day period, remedial activities that have the potential to generate air emissions, and those where off-site receptors may be impacted. By off-site receptors, we mean residences, schools, childcare centers, commercial, industrial establishments off-site, any type of receptor off-site. Off-site receptors can also mean receptors on the site where remedial activities are occurring, but not associated with the remedial operations. Next slide. So in our PAM technical guidance, we go through and detail 7 steps for developing a PAM plan. Yesterday, Dr. Deborah Barsotti covered the first 3 steps for PAM plan development. The first being identifying contaminants of concern. By the time that you're at the point where you're going to be developing your PAM plan, it's assumed that you have a robust data set and that you have fully characterized the site. In addition, you have selected your remedial activity that you're going to use, and that you have a very good understanding of the contaminants of concern at the site. Step 2 is where you're going to identify potential airborne exposures, and this kind of goes hand in hand with step 1. At this point, you're going to use your conceptual site model to determine whether potential airborne exposures are an issue and potentially present as part of your remedial activities. In this CSM, you're going to be evaluating the site layout, what the remedial activities are there off-site receptors nearby, the contaminants of concern, and identifying whether potential airborne exposures are possible. And then the third step is where you establish your health-based threshold values. From here on out, I'm going to refer to them as HBTVs, and response levels. You can do this with the PAM calculator, and then there's also the user's guide that gives extra tips for using the calculator. Both Alan Motter and Emmanuel Gettelfinger went over those in yesterday's training. We focused a lot on going over the HBTVs and response levels, but because they are new terms introduced in the technical guidance document, I just wanted to go over them one more time this morning as a refresher. The HBTV is a contaminant-specific, not to exceed concentration that's averaged over the workday. Typically, HBTVs are compared to laboratory data as they are contaminant-specific. There is some real-time monitoring methods such as a field GC where you could compare that data to your HBTV, but typically it is analytical data from the laboratory. Due to this fact, you're not going to have your data right away, and you're going to have to wait a couple of days until you can compare. So because of that, we've also we're going to be establishing response levels to be used with real-time monitoring. The response levels allow the investigator to evaluate air concentrations and proactively implement steps to mitigate potential air emissions before they occur. The response levels are based on the HBTV, but take into account the capabilities of your real-time instrumentation as well as site-specific data in their development. Next slide. Yesterday, Bruce Groves went over steps 4 and 5 of perimeter air monitoring plan development. Starting with step 4, this is where you're going to identify your monitoring methods and your technologies. By the point you've reached step 4, you know your contaminants of concern, you've calculated your HBTVs and your response levels, so you know what contaminants you're going to be monitoring for and what levels you need to get down to. And using that information, you'll select your real-time monitoring equipment and what analytical methods you're going to need. For step 5, this is where you identify your sampling and monitoring locations, as well as the schedule of your monitoring. You'll determine the number and the location of your monitoring stations based on the remedial activities that are going to be performed, the size of those remedial activities, and where off-site receptors are present around the site. You're also going to determine whether you're going to be using fixed or mobile monitoring stations, as well as the frequency of sampling. It's assumed that real-time monitoring is going to occur whenever remedial activities are taking place that have the potential to generate air emissions at a minimum. For confirmatory sampling, it's recommended for the first 3 days of remedial activity that confirmatory samples be taken, and then that data evaluated to determine if the frequency of confirmatory sampling can be reduced or whether daily sampling should continue. Next slide. Okay, so that was the brief overview of yesterday's training. I simplified it. For today's training, the topics we're going to cover, I'm going to start off by going over the final 2 steps of the PAM plan development, step 6 and step 7. Step 6 being where you select actions to address exceedances of the HBTV and response level, and step 7 where you review your PAM plan, document modifications, and other documentation of exceedances and QA data and results. Next slide. Following that, Robert Scotto is going to give a presentation on quality assurance considerations for perimeter monitoring. And then following that, Bob and myself will cover additional considerations, including contaminant-specific concerns, asbestos, air permitting requirements, how to handle hotspots as part of a perimeter monitoring plan, and best management practices. Next slide. Following that, Amanda Gettelfinger is going to present a case study, and then Alan Motter is going to finish the day by going over the department's technical consultation process. Next slide. Okay, so you're not rid of me yet. So I just went over the overview and topics for today. Now I'm going to dive into covering step 6 of PAM plan development, which is where we're going to select our actions to address exceedances of the response level and HBTVs. Next slide. All right, so first I'm going to cover actions to address exceedances of the response level. The response level is used in conjunction with real-time monitoring instrumentation. The data is typically evaluated in 15-minute time-weighted average increments. However, it could be less than that. You could use 5-minute TWAs, or you could even use instantaneous measurements as a tool. Next slide. Okay, in the slides to come, I'm going to go over a hypothetical scenario. Let's assume the site is going to be addressing soil contamination, various metals, and remedial activities selected are going to include excavation and off-site disposal of soil. So there's going to be a lot of trucks coming in and out of the property as well. HBTVs and response levels were calculated for the purposes of real-time monitoring. A dust meter is going to be used, and the response level is going to be 150 micrograms per cubic meter, which is equivalent to the National Ambient Air Quality Standard for PM10. We went over this briefly, but just to provide a refresher, back in 2013, when the Department's Science Advisory Board reviewed our draft perimeter monitoring guidance and provided recommendations to charge questions, it was determined that we should not be exceeding the PM10 max. So we're using that as our ceiling limit. And since the response levels for the site-specific contaminant calculations were all higher than that, we're defaulting to 150 micrograms per cubic meter. Okay, so we're going to start off our day. Remedial activity is underway. Perimeter monitoring is going on, and we have an exceedance of the response level at the perimeter of the site. So our first 15-minute time-weighted average has been exceeded. At this point, we're going to evaluate remedial activities. Is there any indication that emissions associated with remedial activities are the cause of this exceedance? Do we see any visible dust? We're also going to inspect the instrumentation to ensure that it's working properly. In addition, we're going to evaluate for potential off-site sources of air emissions. For example, are there trucks idling right off the site perimeter that could have been causing this exceedance? And we're also going to consider meteorological conditions. Meteorology can have a big impact on real-time instrumentation. For example, if it's a very humid day, that can cause higher concentrations of particulates. In addition, wind speed can have a huge impact on your air concentrations. So while this is all occurring, remedial activities can continue, perimeter monitoring can continue, but it's important that the exceedance be documented as well as the actions be documented that were taken. This documentation will be included in your final PAM report that should be submitted along with your remedial action report. Next slide. So we're continuing to conduct remedial activities, we're continuing to monitor, and we have a second exceedance at the perimeter of the site. So the second 15-minute TWA has been exceeded for a total of 30 minutes at this point. We're beginning to suspect that the exceedance is due to remedial activities, so we're going to implement dust corrective measures. This could include the application of water on the contaminated areas. It could be tarping stockpiles. It could also involve adjusting the size of the remedial area, making it smaller, or reducing the rate of emissions generating activities, not excavating as much or not having as many trucks coming in and out of the site. Again, you're going to document the exceedance and the actions that were taken. Next slide. We're still conducting remedial activities, still monitoring, but now we have a third exceedance at the perimeter of the site. This is the third 15-minute TWA for a total of 45 minutes. At this point in time, we're going to continue to implement dust corrective measures, and we're going to do whatever additional measures we can, such as modifying remedial operations. But we're also at this point going to collect a confirmatory sample to get a better idea of the contaminants of concern associated with these exceedances. Because this exceedance happened within the first 45 minutes of the workday, we are able to take a full 8-hour confirmatory sample. However, that's not always going to be possible. This might happen later in the day, or you just didn't have confirmatory sampling planned for that day. It's not part of your schedule. So an option that we discuss in the guidance is to collect a 1-hour confirmatory sample option. Now, it's understood that this is not over the full workday, so it's not for direct comparison to your HBTV, but it will give the investigator an idea as to what contaminants of concern are present and the concentrations. So it's a tool to figure out if you're potentially exceeding your HBTV. Again, you're going to document the exceedance, the actions taken, and your analytical results, and those will all be included in your final PAM report. Next slide. So up until this point, remedial activity is still underway and we're still monitoring, but we've now had our fourth exceedance at the perimeter of the site for a total of 60 minutes. At this point, we're going to stop remedial operations because we do suspect that it's associated with remedial activity, and we're going to determine the source of the emissions and how we can reduce it. Is it due to meteorology? Is it high wind speeds? If that's the case, perhaps we just need to stop remedial activities until wind speeds die down. Can we modify our remedial operations some more or use additional corrective measures to reduce emissions? These are all things that should be considered at this point and employed. Next slide. If it's determined on that day that remedial operations can resume and the issue has been resolved, that is fine. However, if the exceedances occur again upon startup, operations do need to be shut down until appropriate emissions controls can be implemented. Next slide. Oh, we have a poll question.
All right, we have our first poll question of the day. So poll question number 1 will be launched, and make sure you answer the question in the window that launches, not in the chat or question box. So the question is, a response level is an HBTV-based time-weighted average screening air concentration monitored in real time. True or false? So the poll window should have launched, and you'll be able to select true or false. Make sure you're answering the poll questions if you are seeking CECs for today's training. That's how we track that you were here. You do not have to get the question correct to qualify for credits. You just have to answer all 3 of them. All right, we'll give you about 15 more seconds. It looks like 90% of you have voted. So make sure you get those votes in if you want your CECs. All right, next slide, please. There we go. The answer is true. Back to you, Erica.
Okay, in the first part of my presentation, we discussed actions to address exceedances of the response levels. We're now going to move on to discuss actions to address exceedances of the HBTVs. As I touched on earlier, typically the HBTV is compared to analytical data from a laboratory. Samples should be collected over the duration of the workday when possible. If you're concerned that you may be exceeding your HBTV or you have exceeded it on previous days, expedited laboratory turnaround time is recommended if possible. In addition, if there's concerns of exceeding your HBTV, there should be engineering controls and work modifications implemented to try to address that. And if it's determined that that is not enough, then remedial operations should be stopped until appropriate alterations can be implemented. Next slide. Some other things to consider. I went over a hypothetical scenario for you with real-time monitoring and response level exceedances, but for both addressing exceedances of the response level and HBTV, there are other things that you might just decide on a more conservative approach. Some things that could affect that would be your proximity to offsite receptors. For example, are remedial activities occurring directly adjacent to a school? If that's the case, you might want to conduct daily confirmatory sampling. You might want to reduce the size of your remedial operations, whatever you can do to minimize potential airborne emissions. Also, the contaminants of concern could have an impact. Are very toxic contaminants present? For example, dioxin. If you have a very toxic contaminant, you might want to be more conservative in your approach. Visible dust leaving the site. We discussed this in the guidance, but I wanted to mention it during the training, that if you see visible dust from remedial operations migrating off the site, this is a cause for concern, and action should be taken immediately to address this, because if you can see the dust migrating off the site, there's a good chance that you could be exceeding your HBTV. Also, best management practices, we should always be implementing those, not only during remedial activity, but during non-working hours, such as tarping stockpiles, whatever we can do to reduce potential air emissions. Next slide. Also, when using your real-time monitoring instrumentation, it can be very beneficial to review instantaneous air data to see if there's sudden spikes in air concentrations, or even if you have pretty big spikes between your time-weighted average increments. This could be an indication that you've hit a hot spot, and a spike could result in an HBTV exceedance. So if there are spikes, inspect your instrumentation and potential sources of air emissions. Next slide. And I can't stress this enough. It's important to document, document, document. You want to document the exceedances and actions taken to address those exceedances, whether they're associated with remedial operations or not. In addition, if it's determined that our emissions are attributable to an offsite source, you should call the DEP hotline at 1-877-WARN-DEP. Next slide. Okay, so that finishes off step 7 of PAM plan development. Now I'm going to cover step 6, sorry. Now I'm going to cover step 7, which is PAM plan review, modifications, and documentation. Next slide. Section 5.7 and Appendix A of the Perimeter Air Monitoring Technical Guidance provide elements that are required in a PAM plan, and this is a snapshot of that which comes out of the guidance, Appendix A. I'm not going to go over all of this in detail, but I just want everyone here today to be aware that this outline does exist in the guidance. Your perimeter monitoring plan should be part of your remedial action work plan. Next slide. Okay, so we've gone over the 7 steps of developing a perimeter monitoring plan, but I just want to highlight the fact that perimeter monitoring is an iterative process. You know, we try to come up with everything we can, all the necessary elements of part of our perimeter monitoring plan, but there will be changes occurring as we're implementing our program as the data rolls in. We're constantly going to be receiving new real-time and analytical air data, and we're going to be reviewing that data. And based on that data, we may be making modifications to adjust potential air emissions, whether that be adjusting the size of the remedial operations or implementing additional vapor or dust suppression methods. When reviewing analytical air data, we may find that our concentrations are well below our HBTVs. And in response to this, we will reduce our confirmatory sampling frequency. Rather than being daily, we might switch it to once a week. It also may be that our analytical error data comes in and we are exceeding our HBTVs. This could be an indication that our response levels are not appropriate, especially if we're not having exceedances of the response levels. In cases like this, we may need to adjust the response levels, make those values lower so we can implement actions before exceedances of the HBTV occurs. Next slide. Here I go again on my documenting. It's important to document everything. Document real-time and confirmatory error sampling data. You're going to document your exceedances and the actions taken to address those exceedances. As that data comes in and you make modifications in response to that data, you're going to document any adjustments that were made to the PAM program, any adjustments made to your real-time response level or frequency of confirmatory sampling. You're also going to document your QA/QC procedures. Next slide. The majority of these modifications and items that you're documenting are going to be submitted in your final PAM plan. And as a result, there's no need to revise your PAM plan, as everything's going to come in your final PAM report that will be submitted along with your RAR. A revised PAM plan is not necessary for modifications such as adjustments to the real-time response level, monitoring technologies and methods, the frequency of confirmatory sampling, the location or total number of monitoring stations, if there are minor remedial operation adjustments. These modifications can be documented in a final PAM report along with their justification. Next slide. There are modifications that would require you to revise your PAM plan, and those are modifications which have cascading effects. An excellent example of this would be adjustments to the HBTV for a contaminant or several contaminants that result in a more stringent value. A more stringent HBTV could in turn mean that you need to change your monitoring methods and instrumentation. It could mean that you need to have more monitoring stations. As I mentioned, it has cascading effects, and because there are so many changes associated with it, a PAM plan should be revised in this case. Another potential cause for a revised PAM plan would be significant adjustments to remedial operations or activities. Also, if contaminants are added to the PAM plan, it's assumed that we have an idea of the site and it's fully characterized, but we might discover while we're conducting remedial activities that there are additional contaminants of concern that we did not originally identify as part of our PAM plan. That would also require a revised PAM plan. Next slide. All right, so this is a snapshot of what should be included in your PAM final report. This can be found in section 5.7.3 and Appendix A of the PAM guidance. And your final PAM report should be submitted along with your RAR. Next slide. The focus of this presentation has been covering New Jersey DEP documentation requirements, but I also wanted to point out that there could be other requirements that are not discussed in our guidance. Those could be at the municipality level or county level, or if it's a larger site, there could be federal requirements under CERCLA or RCRA that would have documentation requirements. Next slide. Thank you.
All right, thank you, Erica. Up next, we have Robert Scotto to talk about quality assurance considerations.
I'm Robert Scotto. I'm with Minich and Scotto. I'm a meteorologist with over 40 years of experience, largely in air quality impact assessments or exposure assessments in support of just Clean Air Act permitting, as well as Superfund air pathway analysis. I also have extensive experience throughout my career in quality assurance, quality control, because much of my work was associated with litigation. Next slide. The topics I'm going to cover is introduction. I'm going to cover what we call the DQOs, or the precision, accuracy, representative, comparability, completeness, and sensitivity attributes of quality. I'm going to talk about planning documents, and I'm going to talk about air measurements sampling versus monitoring, and how the attributes of quality relate to each of those. I do want to say that the quality attributes or big quality DQOs are prerequisite to what Bruce Groves discussed in step 4, which is the selection of the technologies, the instruments, the methods that you're going to use. So they have to be established initially, or prerequisite to that. Next slide. The PAM objective is to demonstrate protection of human health from exposure to air emissions associated with the remedial action. Now, the quality of the data is only meaningful as it relates to its intended use. This means provided you have true demonstration that at the sensitive receptor locations, the health-based threshold values have not been exceeded. You have to have true documentation of that. Next slide. Now, Parks criteria is, some of you might have heard of this, but this relates to the elements or the attributes of quality. We got precision, that's with a P, accuracy with an A, R for representative, C for comparability, and then C for completeness, and S for sensitivity. Parts criteria comprise the program's data quality objectives. So when we talk about DQOs, we're talking about it with respect to each of these attributes. Next slide. What is a DQO? The DQO is a performance and acceptance criteria established to support the collection of scientifically reproducible and reliable data. Next slide. Now, we have a section 6.0 within the PAM document, and that's where we talk about the data quality objectives or parts criteria with respect to the PAM plan, but other information is provided on these attributes in detail in previous CSRR documents that were published or developed in 2014. These include the Quality Assurance Project Plan Technical Guidance and Data Quality Assessment and Data Usability Evaluation Technical Guidance. You should be familiar with these documents. They do provide a lot of helpful information. Next slide. Getting into each of these criteria, precision is the closest of agreement between a series of measurements. It doesn't necessarily mean the measurement is accurate. It could be biased, but you're getting consistent readings on the instrument. Accuracy is the agreement between the measured value and the true value. Representativeness is how well the measured data quantifies the exposure concentrations in the community of concern. Comparability refers to the equivalency between sets of data. In other words, sets of data collected using the same methodology, the same SOP. If you're using differing SOPs, or methods during different phases of your project, that could represent a quality issue. Completeness is the amount of valid data required to support project decisions. Typically, you do this during the workday when you have the remedial action is being performed, but you also have to be aware that the remedial action may require removal of hazardous waste or contaminated soils, which are put into stockpiles. And even though you may cover, tarp, foam the stockpiles, you may have emissions associated with them, and suspected associated with them, and you may want to do monitoring 24/7 in those cases. Sensitivity is the capability of the measurement method to quantify an ambient concentration below its level of concern. Of course, that would be the health-based threshold value, and of course, the response level. Now, I do want to talk about this a little bit in an example. I was retained as a technical expert in a high-profile legal case, and we had a situation where there was a tremendous amount of data, PID data, this would be the monitoring data for looking at compliance with the response level, that was collected by the responsible party. But in parallel to that, there was coincident data collected by EPA. The data sets did not agree. The issue was that they weren't comparable. And what it turned out to be, it was a situation where the data collected by the responsible party and the responsible party firm, there were technicians that used that data, was suspected of not being properly trained in zeroing the instrument. they were getting consistently much lower readings were made by the responsible party as compared by the confirmatory EPA sampling in the same space and time areas or realms. Next slide. Planning documents. Now you have two basic components or types of planning sections in your document, or separate documents if you choose. The PAM plan represents the program objective that provides the references for sampling and monitoring standard operating procedures that you would be employing. The quality assurance plan presents each of the data quality objectives, those PARCS criteria that I talked about, and it basically provides justification as to why you set the specifications for each as such, in terms of so that you would ensure collection of the data that would be useful or meaningful in determining your compliance with action levels or HPTVs. Now, it's generally acceptable to incorporate these two components or these two elements into a single work plan. Next slide. Now, getting into types of measurement methods and how the data quality objectives relate to each, I'm going to talk about some sampling and analysis methods and two categories of methods. That is a sample collected by absorbing media or evacuated canister, e.g. TO15, and analyzed at a laboratory, typically off-site. Real-time monitoring could be contaminant concentrations read directly from typically from a handheld instrument. They're not compound specific. You're talking a PID or FID for TVOCs, or a dust track perhaps, or something like that. Appendix E provides a detailed listing relating the DQOs to the types of instruments used in the document. Next slide. Highlighting this DQO applicability for sampling and analysis. The sensitivity is perhaps, I know it's the last in the PARCS criteria, but it's perhaps the most important. It is making sure you select an appropriate method with an appropriate sensitivity level that's meaningful for the action level or HPTV you're evaluating. Well, in this case, it would be the HPTV. And that would be a New Jersey certified method would be used. Now, if you have an alternative method, technology is evolving all the time. There's better methods and better procedures for doing things, and you want to have it considered for use at your project, you must contact the Office of Quality Assurance, the DEP Office of Quality Assurance, for methods that are not yet certified, to get some sort of approval for that before you do that. Precision and accuracy, analytical, field sampling related error is the collection of quality control samples such as trip and field blanks and field duplicates. Laboratory analysis related error, you do the analysis you're using a NELAP laboratory, and they would include method bank blanks and spikes to evaluate error associated with the analysis method itself, the sample analysis method itself. Next slide. Going on with sampling and analysis, representativeness is the actual exposure based on project duration. Spatial locations representative of the most vulnerable potential receptors would be where you would sample or collect samples from. Temporal would be health-based threshold values. Averaging period is typically 20 to 225 days and 8 to 12 hours that's set forth in the document. And you got to consider background attribution. Deborah talked about the ubiquitous concentrations of benzene and naphthalene that are found in New Jersey, most areas in New Jersey. Comparability is sample collection and analysis. The method must be consistent over the project duration. If you're sampling for VOCs, typically people use TO15. I know that method, NIOSH 5506 is somewhat equivalent, but you should use the same method throughout. You shouldn't change the approach or the method for collecting and analyzing the sample. Next slide. Sampling and analysis continued. This is very important. I can't emphasize this enough. Sample chain of custody documents must be properly completed at all times based on my experience in evaluating data for litigation issues. And field documentation goes without saying. Sample location maps, logbooks, photos. Don't cut the amount of field documentation you do more than is necessary. Is always a good practice, actually. And then data reporting and validation pursuant to NJAC 726 Appendix A. You got data package and summary report requirements, and you got laboratory analysis and validation documentation requirements. Moving on. Real-time monitoring. Okay, this is addressing the DQs associated with real-time instrumentation. Sensitivity is based on the program's action level or response level, I should say all the time here. It's the instrument selection. Select an appropriate instrument. Precision and accuracy is validated or confirmed through factory calibration, site and setup and inspection of the instrument to make sure it's operating properly, field calibration, that would be performance checks, and field duplicate measurements side by side. Typically you use more than one of these instruments on a site, several I would assume. They're switched out. Make sure they're operating and measuring comparably in the same environment. Next slide. Representativeness is the maximum potential short-term exposure. Spatial locations downwind of maximum emissions, i.e. hotspots. I'm going to go into detail on that a little bit later in this presentation. And temporal, response level averaging times, they're generally 5 to 15 minutes. Typically 15 minutes is the time used. Comparability, instrument technology consistent over the project duration. If you're using a PID, use the same instrument manufacturer PID over the whole project to avoid questioning on data comparability issues. Next slide. Measurement traceability. This is extremely important for this, and often it's overlooked. Instrument model number and serial number that's used has to be associated with each measurement. Field documentation, again, measurement location maps, logbooks, photos. Calibration, extremely important. Manufacturer calibration certificate must be kept on record. Field bump tests and calibration associated with each set of measurements that you're doing. Field bump tests are important to evaluate whether alarm levels are working. And then, of course, zeroing. If it's not done properly, your measurements will be biased. Next slide. And measurement reporting, NJAC 726I-627. Data processing software should be provided when requested. Raw data upon which the concentrations are based. Sometimes these instruments all these instruments are basically set up to collect data, report data on a 1 second or 1 hertz basis. However, when you're doing time-weighted averages over 15 minutes, that's 900 samples. The process in which those 900 samples are calculated should be documented, that average. Next slide. And that's it for this segment. Thank you.
All right, thank you, Robert. Up next, we have Erica, and Robert will also be back to talk some more.
All right, hello again, everyone. I'm going to be covering other considerations, other things to keep in mind as you're developing and implementing your perimeter monitoring plan. Next slide. All right, so I'm going to start off this section by covering the first few topics, and then I'm going to hand it off to Robert Scotto to cover hotspots. So starting off, chemical-specific concerns. This is particularly in relation to polychlorinated biphenyls, PCBs, mercury, and naphthalene. The PAM guidance recognizes that PCBs, mercury, and naphthalene can be present in ambient air in both volatile and/or particulate forms. This has implications for the development of your response levels as well as your real-time monitoring instrumentation. When dealing with response levels, we touched on this briefly yesterday, but in those calculations, you're taking into account site-specific data. For contaminants that are considered to bound to the particulate, we'll be using soil concentrations. For those that can be volatile, we're determining the percent volatile of the total volatiles. Because of those calculations for the response level and how they're determined, that can make things a little bit tricky for PCBs, mercury, and naphthalene. The reason we do this for these three contaminants, groups of contaminants, is because mercury and naphthalene are both recognized as volatile contaminants in the department's vapor intrusion technical guidance. And PCBs were recognized as volatile in certain circumstances by the department's Science Advisory Board when we received those responses to charge questions back in 2013. Next slide. Regarding real-time monitoring, there is instrumentation available for mercury and naphthalene that can be used. However, volatile PCBs, it's not readily available or practical. In addition to instrumentation that's available for real-time monitoring, there are some issues for the development of response levels. When you're running the perimeter monitoring calculator, it will give you both response levels based on particulate and response levels based on volatile for mercury and naphthalene. It will not do that for PCBs, and that is because PCBs are a mixture of congeners. So you need to know that congener-specific makeup in order to calculate it because molecular weights are taken into account. If you have that, you can reach out to the department and we can help you develop a response level. Because there are limitations for real-time monitoring, particularly of PCBs, it is recommended that analytical sampling be conducted for all of these contaminants at the start to determine what concentrations are present and whether they're in the volatile or the particulate phase. Next slide. In addition, for that confirmatory analytical sampling I just mentioned, we recommended that that be conducted for at least the first 3 or more days of remedial activities. If you don't have your data in for the first day, by the end of the 3rd day, you should continue to collect confirmatory sampling until you are aware of the concentrations and whether it's particulate or volatile. In addition, confirmatory analytical sampling should always be occurring when the highest of contaminants of concern are present. So when you're remediating those, hotspot areas. Next slide. All right, so we have a section in the guidance discussing asbestos. Asbestos is not included in our perimeter air monitoring calculator, but we do mention that a level of 0.01 fibers per cubic centimeter of air be used for asbestos. This comes from the federal criteria for asbestos abatement in schools, and it has been used before for remediation projects in New Jersey. There is no real-time monitoring instrumentation available for asbestos, so daily analytical sampling will need to be conducted when remedial operations are happening, and that should be conducted using phase contrast microscopy. While you do have to conduct daily analytical sampling for asbestos, if you want to have an idea for real-time monitoring, you can use PM10 in conjunction with that, but use of PM10 is not going to alleviate the need for the phase contrast microscopy analysis. Next slide. The guidance also touches upon air permitting requirements. I want to make it known that air permits are not required whenever you have a PAM plan. They're also not required for the movement of contaminated material. An air permit may be triggered if equipment for operations at a remediation site belong to a significant source category that can be found in New Jersey's air permitting regulations in subchapter 8, specifically 8.2 C2. In there, there's examples of where an air permit may be required and what the levels are. And those include in situ stabilization, soil vapor extraction, as well as thermal treatment. In addition, an air permit may be required for emissions of odorous contaminants, and an odor management plan would be required in those cases. Contacts for air permitting and additional information can be found in the perimeter monitoring technical guidance in the other considerations section for air permitting requirements. Next slide.
Hi guys, it's time for poll number 2. So poll number 2 states real-time monitoring stations at the perimeter can be mobile, stationary, or a combination of both. Please answer A, true, or B, false. I'll give you guys about a minute. Okay, everybody, our polls are closed. So the answer was true. This statement, real-time monitoring stations at the perimeter can be mobile, stationary, or a combination of both, is true. Thank you very much. Erica, you may continue.
Thanks, Ryan. All right, I'm going to continue on with the discussion of best management practices. Best management practices should be employed during working hours and non-working hours. So not only when remedial operations are underway, but also when they're not. Best management practices could include the wetting of areas, the application of tarps, foam on stockpiles. It could also include avoiding emissions generating activities or windy days, or modifications to the size of your remedial operations. In addition, if there is concern that best management practices may not be protective enough, in these situations, it may be appropriate to implement 24-hour perimeter monitoring to get a better handle of what the air concentrations are and if there is a risk to off-site receptors. Next slide. All right, I'm going to pass it off to Robert.
All right. Robert Scotto here again, Minich and Scotto Incorporated. Actually, I'm going to talk about hotspots. This is a critical issue since we evaluate whether we're going to be complying with HBTVs or the health-based threshold values based on the short-term monitoring or the response level compliance. Next slide. I'm going to go over the hotspot definition, which is set forth in the PAM document. I'm going to go to talk about soil treatability considerations. And I'm going to talk about real-time monitoring methods. I'm going to talk about an approach that might be used when you're dealing with a hotspot issue. And then response level compliance. Next slide. Hotspot definition is the unanticipated concentration levels in the soil which exceed the remediation standard or background concentration by a factor of 10 or more. Next slide. Now, because hotspots may cause acute exposure to the downwind community, all monitoring must be performed in real time. In other words, it may cause an HTB, health-based threshold value exceeded to the downwind exposures, downwind community. That's really what we're getting at here. Now, while certainly necessary, such monitoring should only be the last line of defense and never the only line of defense. Next slide. Now, why do I say never the only line of defense? Well, with soil treatability considerations, the selection process of the remedial alternative should not only look at the end product of the remediation or when the site is remediated and suitable for redevelopment, such as putting a new building on it, but it also, during that process and during the time when you're looking at remedial alternatives, you should also evaluate potential air emissions, especially when you're doing things like ISS or thermal treatment or something along that lines. And that typically requires performance what they call a bench scale or pilot scale study. Now, compliance with the health-based threshold level then should be demonstrated, can be demonstrated in advance using the data collected about air emissions during those studies. And then that information could be part of the process, or a good part of the information that's used in ultimately selecting an appropriate remedy. Emission factors are measured during these treatability studies in terms of a mass of emissions emitted per unit volume of material remediated, treated, soil treated, and it should be derived, and these should be measured and scaled up during the treatability study, and then scaled up to reflect the actual rate of remediation that's going to be performed when the remedial action is implemented. A demonstration with the health-based threshold level is accomplished initially on paper using a dispersion model. Or you can use a simple nomograph based on dispersion modeling, which simply concentration on the vertical axis as a function of a downwind distance. Next slide. Now, Bruce Groves talked about these instruments at length yesterday, but typical real-time monitoring methods used are handheld instruments. Again, your PID, your FID, your dust track, instruments of that nature. But there is a standoff technology which was developed by EPA about, it's going on 20 years ago. It's called TO16. It's Fourier Transfer Infrared Spectroscopy. And what this is an analytical method. It's actually taking the laboratory FTIR analysis method and putting it into the open atmosphere. The atmosphere is actually the measurement cell. And basically it has some advantage, but then again, hasn't been widely used. Next slide. Now here's a typical site. I'll explain the situation on this, why traditional monitoring methods don't always cut it, and may not always, traditional point monitoring methods may not always be appropriate. When you have a hot spot, and you have that occurring with that in situ soil stabilization processing activity, say occurring during weather conditions where wind direction where wind data isn't very discernible. In other words, you may have very light winds. If you're using cup and vane anemometers, it might be below their threshold, but yet there is wind movement. There is migration of sources with the general bulk transport of the atmosphere. You can have a situation where you have an exceedance, or that occurs at the fence line, and then occurs ultimately at your sensitive receptors. What is done here is that there has to be an approach made to be able to detect when this is occurring. And usually that involves the use of current methods would involve a more robust use of the handheld PID or FID or an instrument of that sort to detect these hotspot emissions emanating from an ISS activity. Next slide. I'm just going to get some concepts here. I'm going to put an approach that could be used to be able to do this. The first is collecting a measurement, because you don't know exactly where that hotspot might end up being, but it is causing a contravention of a response level off-site. You collect the path average concentration by walking a handheld instrument along a measurement path downwind of the hotspot over a 15-minute period. Typically, it could be less than that or more than that. Typically less than that. Or, you could also look at instantaneous measurements to determine if you have a problem in the first place. But viewing the 15-minute period yields a mean or average concentration along that measurement path. And that's called the path average concentration. And then that 15-minute average concentration is reworked to yield an adjusted downwind concentration. It assumes that most of the emissions are emanating from that single small hotspot where there might be ISS activity, where the ISS mixing activity is going. You're adding Portland cement, for example, to the soil, or you're using thermal heating. And it assumes that the dimension is equivalent to the dimension of that processing location. We're getting into a couple examples. Next slide. Now I'm going to show two examples. This is one example with 3 steps where we're not exceeding the response level. And then the next 3 examples, 3 steps where it's exceeded, to make it clear. First, you make a 15-minute path average concentration. If you see that gray line on the figure, that's where you walk back and forth in a uniform manner using the PID. Let's assume you measured a 20 ppb path average concentration over that 50-meter measurement path, and your response level is 0.5 ppm. Next slide. Step 2 is simply assuming a conservative hotspot or remediation area width. You assume, for example, the hotspot width is 5 meters at the fence line. So you use that hotspot width to assume that all the emissions that you measured in that path that you were walking were actually concentrated in that smaller plume, in that plume dimension. Next slide. You calculate the adjusted downwind concentration and compare it to the response level. The adjusted downwind concentration is simply the path average concentration, the 20 ppb, times the measurement path, which is 50 meters, divided by that hotspot which is 5 meters. You get an adjusted concentration of 200 ppb, which is 0.2 ppm. The response level in this case would not be exceeded. You get a preliminary assessment that you're okay in this situation. On the other hand, getting into the next example where we are exceeded, next slide. We take the same 15-minute path average concentration reading along the downwind measurement plant. We assume that there's 100 ppb path average concentration over a 50-meter measurement path, and we have the same 0.5 ppm response level. Next slide. Again, assuming a conservative hotspot plume width of 5 meters. Go to the next slide. We calculate the adjusted downwind concentration and compare it to the response level. The adjusted downwind concentration is the path average concentration times the measurement path divided by the hotspot width. That would be 100 ppb times 50 meters divided by 5 meters. That means you have an adjusted downwind concentration at the fence line of about 1 ppm. And in this case, you have a great potential that you're exceeding the response level, and appropriate actions have to be taken. Okay, next slide. One thing I do want to make sure you understand, when we were doing a situation, I had a site situation like this, the actual site boundary was on one side of a creek or a water course separating it from the downwind community. It was a relatively narrow water course. Nevertheless, it was 20 meters further to the nearest public access or residential access location. So we were able to do some quick modeling using the conservative, least dispersive daytime atmospheric condition to determine, well, how much would that plume be diluted if it's traveling that further 20 meters downwind of the fence line. So what we did was we did modeling to come up with these dilution factors, and we assumed that the dilution factor, we predicted, that conservatively predicted, because it was a UCPA model doing this, that was 0.300, and we were able to adjust that downwind concentration by 70%. So, and as it turned out, at the sensitive receptor, we ended up having a concentration of 0.3 ppm or 300 ppb, which was less than the 5 ppm or 500 ppb response level. Next slide. Now, before I get into this, I do want to say that, when you have a situation like this, you've got two alternatives. It could be associated with perhaps not very common meteorology. You just ended up being in a situation where it was a stagnant day, there was very little wind. You basically could have the alternative of just curtailing remedial activities during that day. But if that's not practical, on the other side of the coin, you often will have, and you can't resolve the situation with the hotspot. It's just happens. You have to do something like maybe modifying the remediation to be done under a sprung structure with an appropriate air handling system to treat or clean the air. And a lot of that information on how you size that air and handling system would come out of a treatability study in which you estimated the emissions associated with the remedial technology ultimately implemented. But that would require, of course, a major modification to your PAM plan. Now, I wanted to show you a screen here. You know, speaking about treatability studies, we were involved in several projects under contract with EPA in my past, where we were actually calculating emissions associated with remedial alternatives being considered. And this is basically an application using, public domain dispersion model kernel. Now, we actually use the AirMod model. And what we did here, you know, typically a model will predict an impact or an exposure concentration from a source, from an emission source. So you put the emission source into the model, you get a downwind exposure impact at a sensitive receptor location. We actually inverted that process where you actually have the known downwind concentration and the distance from which that downwind measurement, that 15-meter path average concentration was made from the hotspot. And we actually inverted it and calculated the source strength to produce that response on the instrument. And by doing that, we were able to evaluate further downwind impacts using forward modeling to determine whether the remedial alternative would work. So this is just an example. It actually requires a little bit more comprehensive, cohesive meteorology. We use traditional, instead of using cup and vein, we usually used a 3D sonic anemometer to get the proper parameters to go into the model. But anyway, next slide. That's pretty much all I have to say. Thank you.
Okay, great. Thank you so much, Robert, and thank you, Erica. We are going to start with audience questions now. So I'll just jump right in. The first question is, does a PAM plan have to be submitted to and approved by NJDEP prior to implementation?
No, it does not. Since it's part of the remedial action work plan, it's not something that would require pre-approval or review from the department prior to implementation.
All right. Is air monitoring required for linear construction where you are continually moving?
So we did receive a comment on that after the guidance was released. It's recommended for these projects that you reach out to the contact for linear construction projects or Amanda and myself for perimeter air monitoring directly.
All right, so the next several questions are from the same person and they're kind of along the same lines, so that might be your answer for this too, but I'll just ask them. Are the 20 days for the entire linear project or just the sections of contamination?
Again, it would depend due to the nature of those projects.
Okay. The next question, is there a mandatory lab turnaround time for the confirmatory samples?
Can you repeat the question, Alyssa?
Is there a mandatory lab turnaround time for the confirmatory samples?
No, LSRP should be using best professional judgment, but keep in mind that, we recommend the first 3 days of remedial activities for confirmatory sampling, but you really should not be stopping your confirmatory sampling until you have data to review. So the sooner you can get that data to review it, the better. If you're finding results that are below your HBTVs, you can reduce your sampling frequency and you might not need to do expedited in those cases. It can be on a regular routine. It just depends. Do you have data on hand yet to determine whether you're potentially exceeding your HBTV? Do you have reason to suspect you might be exceeding your HBTV? Under those scenarios, the sooner the better.
All right, canisters need to be ordered in advance and have a shelf life. How can you be prepared to take a confirmatory sample same day?
I've had some experience with this. You should have, 1, maybe 2 canisters on hand. They do have a holding time. The reality is there are possibilities where you won't be using those shorter duration confirmatory sampling canisters and they'll need to be returned to the lab. You won't have to pay for the analytical fee to get the results or anything, but I'm assuming there could potentially be a cost associated with the delivery and the calibration of those canisters. With that said, it is one of those things that we have as a suggestion, like a strong suggestion in the guidance, but depending on site-specific characteristics, they may not even be necessary.
All right. If the 1 hour confirmatory sample shows that despite the 4 exceedances, the contaminant of concern concentrations were non-detect, is it okay to not stop work in the future?
Yeah, I think I understand what they're after. Yeah, in this scenario, you can use a lines of evidence approach. You could start remedial activities again. But if there's still concern you're exceeding your HBTV, to get a full workday sample would prove helpful. Maybe take those more frequently than you were planning to. It really would be a site-specific scenario. Another option could be, Amanda's going to cover this a bit in the case study, and we talk about it in the guidance as well. But another tool you could use for scenarios like this, if you only have 1 or 2 contaminants of concern, obviously you can't do this for everything, it would be a bit overkill, but the use of colorimetric tubes could be a useful tool, that if you have an exceedance of your response level, using a colorimetric tube to determine is it your contaminant of concern, that would give you information sooner. So that's another option as well for those cases.
One thing, can you hear me?
Yes.
Okay. One thing I might add is if you are seeing exceedances of response levels, but your confirmatory samples show you are well below your HBTVs, you may in fact adjust your response levels, because there may be something that you're seeing in your instrumentation that we didn't account for in the calculations.
All right, the next question is, what kind of sampling are we talking about? SUMA canisters, what sample duration, and what flow rate?
So the answer for, shorter duration confirmatory sampling is what I am assuming that question is referring to. It will be specific to the type of exceedance that your real-time monitors are exhibiting. So if it's the dust monitor that's alarming, then you're not going to want to grab a SUMA canister sample. You're going to want to use whatever your particulate analytical method is. As an example, TO13A. And then as it relates to the duration, you could do a 1 hour sample. You could also do, as Erica mentioned, in a more conservative approach, is the rest of the day duration for a sample. If you are doing a 1 hour confirmatory sample using a SUMA canister, they do have 1 hour flow controllers.
All right, the next question is, how are odor complaints from receptors handled in the PAM plan?
So we touch upon this a bit in the guidance document. If there are odor concerns, this is where the air program would get involved, particularly air enforcement, and there would be a development of an odor management plan on how to handle these issues. Odors are a little bit more tricky. Dr. Barsati touched on this yesterday, that you might smell an odor before I smell an odor, or vice versa. So it's really indicative of, are there concerns from receptors or those working on the site? There are odor thresholds that could also be used as, a guide. But yeah, if there are odor concerns, the AIR program would get involved, and an odor management plan would need to be developed and implemented.
How is notification to DEP, if required, included in this PAM plan if there are exceedances identified?
So the documentation of exceedances and actions to address those exceedances would be incorporated in your final PAM report. If there are multiple HBTV exceedances and there are concerns, you can always reach out to the department. Both Amanda and myself are listed as contacts for that.
All right. Is the 15-minute sampling period a rolling average?
Do you mean the 15-minute time weighted average? I'm assuming that's, and the answer is yes, it's a rolling average.
Can you again explain confirmatory sampling as a means to confirm exceedances observed from the real-time monitoring? Is this a sample collected in a cartridge, for example, and sent to a lab, or can confirmatory sampling be done in real time?
That is sort of a two-part answer, and the answer in certain situations is yes to both of them. As Erica mentioned, one way to do a confirmatory sample in real time for VOCs is to use a colorimetric gas tube specific to whatever your driving VOC is for the site. However, in most cases, when we're speaking about confirmatory analytical sampling, we are referring to the collection of a sample on some sort of media that does need to be submitted to the laboratory for analysis.
And it would depend on the contaminant as well. For instance, with volatiles, you might be using a SUMA canister. For particulates, you might be using the filter from the dust monitor and sending that off for analysis of metals or whatever your contaminant concern is.
All right, the next question is, if you revise the PAM plan as discussed on slide 49, should this revised plan be submitted to the NJDEP? And if so, who should it be submitted to?
So we've
Exactly
discussed
on
this.
slide 49. But I can speak to it.
Yeah.
So as I covered in the first question, a PAM plan is not going to be something that's reviewed and pre-approved by the department, as it is part of a remedial action work plan. So whether the remedial action work plan is submitted as a document on its own or it's submitted along with an RIR or an RAR, it's all dependent upon that.
Are field blanks and duplicate samples always required for confirmatory analysis?
Generally, you just want to follow the general QA/QC procedures that Robert Scotto had outlined. So, and what's in the field sample procedures manual. So, ideally, you would like, duplicates and trip lengths and all sort of stuff, but it's not always practical to do that.
Can you please define under what conditions or circumstances PCBs would be considered volatile?
Sorry, Alyssa. Sorry to interrupt. I think Robert had more he wanted to add.
Oh, I'm sorry.
Okay, I'm on. Yeah, you do want to do enough QAQ samples, especially if in the field, to ensure that you have a means to quantify the precision and accuracy, or better said it other ways, the measurement error associated with the field data, field sample collection process. So whatever's appropriate, there is SOPs out there that tell you exactly what you should do.
All right, the next question is, can you please define under what conditions or circumstances PCBs would be considered volatile?
So yeah, I can speak to this. You need to provide a justification, and it's also going to tie to what remedial activity you're using. Are you going to be using thermal treatment? Certain things could have more tendency for PCBs to volatilize. But again, you're going to be relying on that confirmatory sampling. That's going to be your indicator. That's the piece of the puzzle that you need for PCBs.
Yeah, generally with PCBs, if it's a thermal type treatment. Yeah, so I remember a case with EPA where they were doing some land farming and they were adding lime to the soil, which caused a exothermal reaction, and the PCBs were volatilizing, and they could actually document that.
The next question is, are you stating that ACM sampling is required for all PAM plans?
Can we define what ACM sampling is?
It just says ACM, I'm not sure.
I'm wondering if it's related to asbestos. Erica.
That's what
Right.
I'm assuming, yeah. So if it is related to asbestos, which is what I was thinking as well, if it involves asbestos, yes.
The next question is, what real-time monitoring is available for naphthalene? From my experience, this compound is very difficult to measure even with a portable GC.
Yeah, I can address that question. I mean, the only mainstream real-time method to, in a sense, monitor a naphthalene is through use of a PID. There is a response on a PID to volatile naphthalene. Also, I do want to mention that that not TO15 but TO16, the open path FDR spectroscopy, is a very good monitor to measure naphthalene in real time, and only naphthalene. It's analytical.
Okay, and a follow-up to that question is it sufficient to use a PID to monitor for naphthalene in real time? Just to make sure that's confirmed.
Yes, if you use an appropriate response factor, you want to look at what component, or you want to make sure that the instrument's detecting that in terms of the electron potential or the lamp that you're using.
The next question is on-site worker protection not included in the derivation of site-specific HBTVs?
That actually is correct. When it comes to on-site workers, that should be covered in the site-specific health and safety plan. The perimeter air monitoring guidance speaks to the inhalation exposure for off-site receptors from remediation areas.
All right, I think we have time for another question or two. Yesterday, a question was asked about the need for confirmation sampling during the use of a field GC. I believe the answer was that confirmation sampling was not required when a GC was in use at the site. Please confirm.
So a field GC would be good because the field GC is giving you contaminant-specific information that can be directly compared to your HBTV. Now, with that said, if you're having levels exceeding that HBTV, or if you're right at it, it would probably be helpful to do analytical sampling sent to a lab on top of that as an additional layer to confirm that.
All right, the next question is, if a remedial action work plan was submitted in October of 2023, is a PAM plan required if RA activities are to be implemented after June of 2024?
Okay, well, I would say the requirement for doing a perimeter air monitoring plan has been in the tech regs since 2012. This guidance has a 6-month phase-in period, so you wouldn't have to follow the guidance until that 6-month period is up. However, if it's a site that perimeter air monitoring should have been conducted, then there should have been some plan in place even prior to the guidance.
All right, and we'll take this one last question. If you have to modify the perimeter air monitoring plan, why not just summarize the changes and modifications in the PAM report and not have to prepare a modified perimeter air monitoring plan?
So in a lot of cases, that will be what you do. But if there is a significant modification that has cascading impacts to your plan, what methods you're going to use, how you're going to implement it, that would require a revised PAM plan. But again, the majority of modifications will not. They'll just be documented in your final report.
Hello, everybody. So that seems to be the end of our question segment. So we're going to take a short 10-minute break so everyone can get up and stretch their legs. And you could all meet us back here at 10:50. That is 10:50. Thank you, guys.
All right, everyone, it is 10:50, so we're going to get started again with the training. Up next, we have Amanda Gettelfinger, and she's going to present a case study.
Okay, hi everyone. Again, my name is Amanda Gettelfinger, and I'm a research scientist in the Bureau of Environmental Evaluation and Risk Assessment. And I'm going to go over the case study that is included in the PAM Tech Guidance as Appendix F. So the purpose of the case study was to try and provide a relatable real-life scenario where PAM would need to be developed so we could demonstrate how the 7-step PAM process would apply. The case study itself is presented in the same order as the steps in the guidance document, and this presentation follows the case study in Appendix F, so you can read along in the tech guidance if you would like to. Next slide, please. So the first section of the case study is the site description, which was included to demonstrate what sort of property the case study was based upon. This usually is covered in the site description of your key document submittals. So typically you wouldn't need to rewrite anything that isn't already written for this, but it's preferred if investigators include this section so the reviewer doesn't have to scroll back to the beginning of a really large document to double check that the information in the PAM plan is accurately addressing site conditions. And I just want to note that the site map provided in this presentation is not of an actual remediation site. We had to find a property that fit most of the site characteristics that we identified in the case study, but it's not a perfect match, so please just bear with me. So moving on, our case study discusses a large site in a highly industrialized area of New Jersey and some of the historic uses and impacts on the property. The previous site uses included shipbuilding, dry docking, and repairs and other industrial processes, and there is also historic fill. The eastern boundary of the site, or the proposed remedial work area, is a residential housing area. The other boundaries consist of the undeveloped tidal marsh to the north, the abandoned piers on the navigable tributary to the west, and warehouses to the south. What's important to note here is the fact that there are residential homes within close proximity of where the proposed remediation is going to occur. So our aim is going to be protective of those downwind receptors. Next slide, please. The next part of the case study discusses the remedial activities at the site and the anticipated duration for which the PAM plan needs to be developed. The remedial investigation has already occurred and the site has been fully characterized, so the site's contaminants and their concentrations have been documented. The case study discusses the projected remediation duration, which is anticipated to last at about 90 days, but for the calculation of the HBTVs, which I'm going to demonstrate in a few slides, we used 120 days as our exposure duration. And that's because we wanted to build in for things like weather and permitting delays. And as it says, for those 120 days of remediation, the anticipated working hours are 8 hours a day and 5 days per week. Next slide, please. For the general purpose of perimeter air monitoring at a site, the case study speaks to designating a full-time field person to be a perimeter air monitoring technician. There are a lot of moving parts when it comes to perimeter air monitoring, including, the real-time and confirmatory sampling, scheduling lab deliveries and pickups, and general maintenance of things, including the equipment, knowing the schedule for confirmatory sampling and all the sampling procedures. So it is really important to attempt to designate a full-time PAM technician to take care of all those responsibilities. And here are some of the responsibilities that are included and the crucial roles that the PAM technician plays when executing the PAM plan. Next slide, please. So the first step in our 7-step process is to identify the contaminants of concern. As I said, the site was historically used for shipbuilding and dry docking and repairs and other industrial processes. There is the presence of historic fill due to its originally low-lying topography. As Deb went over in her presentation, adequate site characterization is required to determine site COCs. So we are relying on site characterization data from previous phases of remedial investigation to determine which COCs will need to be monitored. Table 1 of the case study shows contaminants that were identified at the site that are likely to be particulate-bound species, and these include semi-volatile organic compounds and metals that were identified at the site exceeding their most stringent remediation standards. Additionally, we have the 95% UCL soil concentrations listed for each contaminant, and using the site data, we calculated the 95% UCL of the mean concentrations for each contaminant. And these concentrations are what was used as calculator input values to develop HBTVs and response levels, which I will go over later in this presentation. Next slide, please. Table 2 shows the VOCs identified at the site exceeding their most stringent remediation standards and their 95% UCL concentrations as well. Note that there is an additional column in this table that is not included in Table 1, and that's That's because as part of the calculation for VOC response levels, the investigator must first determine the percent of an individual volatile per total volatiles at a site. And the total volatiles at the site refers to the summation of all concentrations of VOCs detected above the the most stringent remediation standards during all phases of investigation. So an example for benzene would be to divide the 95% UCl concentration of the benzene data set by the summation of all VOC concentrations at the site. The percent of total volatiles equation is included below table 2, and it's denoted by the double asterisk. And the individual VOC soil concentration in the equation is where you would use that 95% UCl concentration found in the second column. Next slide, please. So after we've established which COCs exceed their most stringent remediation standards, then we move on to step 2, where we identified potential airborne exposures. As Deb previously mentioned, this is where we developed a comprehensive site-wide conceptual site model. And as part of the conceptual site model, we considered the site-specific COCs, the nature and extent of contamination, the type of remediation options being proposed, the fate and transport of contaminated media, and off-site receptors that could be impacted by the COCs. And again, we will note that on-site worker health and safety is going to be covered in the site-specific health and safety plan. So during the development of our CSM, we identified that the most important and sensitive receptors who could be negatively impacted by migrating contaminant plumes were the residential neighborhood to the east and the off-site industrial complex and workers to the south. Our proposed remediation will include excavation and off-site transport of contaminated soils, as well as some temporary stockpiling, soil loading, and soil regrading. And contamination at our site is not concentrated in one area, so site-wide remediation will occur. After the development and review of the CSM, we identified that the only exposure pathway applicable to PAM is the inhalation of airborne organic vapors and contaminated particulates. So this is based on exposure to contaminants in the air based on remediation activities and is not directly tied to the inhalation exposure pathway addressed in the soil remediation standards. So HBTVs and response levels for the site-specific COCs were developed to address inhalation exposure from remediation. Next slide, please. Step 3 of the process is calculating the health-based threshold values and response levels for each contaminant at the site that exceeds its most stringent remediation standard. As we previously stated in Deb's and Alan's presentations, health-based threshold values are daily average concentrations for individual COCs that are not to be exceeded to protect off-site receptors. Response levels are contaminant-specific concentrations that are calculated using the same information as those HBTVs, but also incorporate site-specific soil data, and they provide for a more realistic concentration to monitor at the perimeter of the site using real-time monitoring equipment. And calculating HBTVs and response levels for site COCs is an iterative process. So as you can see on tables 4A and 4B, we have calculated the HBTVs and response levels for each COC that we identified in tables 1 and 2 earlier in this presentation using the department-provided calculator. As the tables demonstrate, the most stringent HBTV for particulates is for benzoate-pyrene, and the most stringent HBTV for volatiles is trichloroethylene. As shown here, mercury does have a lower HBTV than for TCE on table 4B. However, it will be monitored separately from VOCs because non-chemical specific real-time monitors are not capable of detecting the mercury vapor fraction, so it's not considered here. And I will go into that a little bit more in the presentation. Just a quick note though, the concentration displayed on the table 4B in the presentation, it shows 0.33 parts per billion by volume. In the PAM technical guidance, it actually says 1.33 parts per billion by volume. The correct HBTV is what is shown here on the slide. and we will make revisions to Table 4B when we do our first iteration of revisions to the PAM Tech Guidance document. Anyhow, these will be the HBTVs for benzoate, pyrene, and TCE that we are aiming to meet at the perimeter during remediation, because it can be reasonably assumed that if these are not being exceeded, then we are being protective of all other contaminants as well. Because the HBTVs for benzoate, pyrene, and TCE are the most stringent, the response levels calculated for those contaminants are what we will be using with real-time monitoring equipment as the not to be exceeded response level at the perimeter. And as you'll note, the response level for our all particulate bound COCs is 150 micrograms per meter cubed, and I will discuss that, why that is, on the next slide. So next slide, please. Here are the examples of input and output values for the calculator. Our examples include contaminants that provided the most stringent HBTVs, which I just discussed on the previous slide. So we have benzoate, pyrene, trichloroethylene, and mercury up on the screen. Alan went into some detail of how you can use this calculator yesterday, so I won't be presenting its full functionality here, but as you can see from the screen capture, we have the exposure assumptions, which we discussed earlier in the case study. And so we have an 8-hour workday and 120 workday duration for remediation. So looking at the inputs and outputs for trichloroethylene, you'll see that we use the percentage of TCE per total VOCs that was calculated in Table 2 as the input value. And the associated HBTV and response level are calculated. And for benzoate pyrene, we used the 95% UCL soil concentration calculated in Table 1 as the input value in the calculator. And the associated HBTV and response level are calculated. You can see that when you are calculating the response level for benzoate pyrene, that we receive an error message to the right of the calculation box, which says that the calculated response level exceeds the ceiling value the department uses for PM10, which is the National Ambient Air Quality Standards, or NAAQS, for a 24-hour workday. And the NAAQS standard for a 24-hour workday is 150 micrograms per meter cubed. So that will be our response level that we're going to be using at the perimeter for particulate-bound contaminants. The reason that Table 4A on the previous slide indicated that the response level for each soil-bound contaminant is 150 micrograms per meter cubed is because during each iterative calculation that we did for all site contaminants, the NAAQS PM10 ceiling limit was exceeded and the calculator defaulted to this concentration as the response level. Then we have the calculations for mercury. Mercury resides on both tables 1 and 2 as a COC identified in soil, indicating that it is a contaminant that can exist both in its volatile form or can be encountered as a soil-bound contaminant. So we followed the steps for calculating both volatile and particulate HPTVs and response levels because we're going to need to determine through analytical confirmatory sampling which form of mercury is present in air, if either. So in the case of mercury, the calculator requires that you enter 100% as the percent of total volatiles in air to develop a response level, because monitoring for mercury will be conducted with a mercury-specific meter rather than a non-chemical specific meter like a PID for the vapor fraction. So the HBTV is automatically calculated with the exposure input data at the top like it is for all the other contaminants. And you'll notice when you put in the 100% for the volatiles in air, the response levels for the volatile fraction are the same as the HBTVs in both micrograms per meter cubed and parts per billion by volume. So the response level for the particulate fraction of mercury is calculated using the 95% UCL soil concentration calculated in step 1. Next slide, please. Step 4 of the PAM process, after having developed our HBTVs and response levels for our site COCs, is to develop our monitoring strategy and technologies that we plan to use at the site to measure and meet our air concentrations. Bruce took a fair amount of time to discuss different real-time monitoring and confirmatory sampling options that can be used. Many more options do exist on the market as well. However, for our site conditions and our receptors, we identified that for real-time monitoring, a photoionization detector or a PID, a dust meter capable of measuring PM10, and a handheld mercury meter were appropriate. We chose a PID to monitor total volatiles at the perimeter. As Bruce discussed, total volatiles is a surrogate or a group of compounds to be measured using non-chemical specific real-time monitoring equipment. Table 5 shows the ionization potentials for each VOC that we have on site. So we chose a 10.6 EV lamp to be used within the PID because the ionization potential of all of our site-related volatiles fall below that measurement. So the meter would be able to detect if any of these contaminants are being emitted from the remediation area, though it cannot speciate which contaminant is causing an alarm condition. For our particulate-bound compounds, we elected to use a dust meter that is capable of monitoring PM10 as a surrogate for the particulate-bound semi-volatile organic compounds and metals. And our response level that will be used for monitoring dust at the perimeter is the National Ambient Air Quality Standard for a 24-hour period of 150 micrograms per meter cubed, as we discussed in step 3. Lastly, because the mercury volatile fraction cannot be detected by real-time monitoring equipment capable of monitoring total VOCs, a mercury-specific meter will be used to monitor the mercury volatile fraction at the perimeter. And the HBTV that was developed in step 3 will be used rather than a separate response level because a surrogate for mercury's volatile fraction is not being used. The particulate-bound mercury fraction will be covered through the use of the dust meter monitoring for PM10. And for real-time weather readings, we are going to be using a telemetry system that will convey the weather results from our weather station. Next slide, please. Okay. As Bruce said yesterday, there are a wide range of different PIDs and dust meters on the market, as well as other real-time monitoring equipment options. So the selection of specific pieces of equipment will ultimately come down to the ease of use and the reliability of the equipment in the field. Another consideration at a much higher level when selecting real-time monitoring equipment is whether its sensitivity is capable of detecting the response levels that we've developed. Also, we've elected to use a 15-minute time-weighted average at the perimeter of our site with our response levels rather than an instantaneous real-time concentration. And that's because a 15-minute time-weighted average response level will allow for our PAM technician to rectify any site-related emissions causing the TWA exceedance at the perimeter without necessarily exceeding the health-based threshold value for trichloroethylene or for benzoate pyrene for the 8-hour workday. It also might allow for an instantaneous exceedance like a spike to be remedied over the 15-minute duration without needing to cease work and reevaluate. The 15-minute time-weighted average will not be used for the mercury volatile fraction, however, because the health-based threshold value will be used as our response level for the mercury-specific handheld meter. Next slide, please. Okay, so next, as part of step 4, we move on to confirmatory analytical sampling methods and technologies, which are used to confirm that real-time monitoring equipment and response levels are protective of the HBTVs we've established. For volatiles, we have table 6 that lists all the selected analytical methods for determining whether HBTVs are being exceeded during the workday. Most of our site-specific volatiles can be detected using the US EPA method TO15, as you can see on this table. The only contaminant that can't be detected using that method is mercury, for which we will be using the modified NIOSH method 6009. And just like for real-time monitoring, an assessment was done as to whether these methods were sensitive enough to meet the HBTVs that we've developed for each contaminant in step 3. Next slide, please. For particulates, we have table 7 that lists all the selected analytical sampling methods for determining whether HBTVs are being exceeded during the workday. Most particulates can be detected using US EPA method TO13A or modified NIOSH method 7303. The only exception, again, is mercury, for which we will be using the modified NIOSH method 6009. And again, like real-time monitoring, an assessment was done as to whether these methods were sensitive enough to meet the established HBTVs that were developed for each contaminant in step 3. We also talk about in the case study the speciation of mercury in air. So as discussed in step 3, mercury is one of those compounds that has multiple fractions in which it can be detected. So we selected confirmatory analytical options that are able to detect multiple fractions. So while we expect mercury to be in its particulate bound form because our site has no soil data that suggests that elemental mercury is present, confirmatory air sampling will be conducted initially to determine which fraction of mercury is present at the site. The modified NIOSH method 6009 comes with a particulate prefilter, and the prefilter will be analyzed for the particulate bound mercury species, while the sorbent material will be analyzed for the elemental mercury species. So next slide, please. Okay, so next we're going to be talking about step 5, which details our real-time monitoring and confirmatory sampling schedule and locations. So here we have the site boundary and the surrounding receptors. As we discussed earlier on, there is a residential neighborhood to the east of the site, an industrial warehouse to the south, the river to the west, and the marshlands to the north. The receptor we should be most concerned with is the residential offsite receptor to the east. When developing our layout for our monitoring stations at the perimeter, we decided that 3 monitoring stations would sufficiently address the community and protect them from offsite migration of contaminants. Those monitoring stations are represented by the 3 yellow dots here on the eastern portion of the site. Then we have 1 monitoring station to the north, 1 to the west, and 2 to the south. The 2 to the south are to protect offsite industrial workers and people in the parking lot associated with the warehouse. All 7 monitoring stations will have the ability to be moved if the prevailing wind direction changes and we feel that the current station locations are not protective of the receptors. So, though it's not anticipated that we're ever going to need to move the western and northern perimeter stations, but in the case of remediation occurring closer to the eastern property boundary, we may elect to concentrate the 3 eastern stations closer together to reduce the likelihood that migrating contaminant plumes will go unnoticed. And I'll go into an example of that on the next slide. So also in this figure, we have the worksite trailers indicated, which is where there's going to be a parking area for on-site workers, though that's not actually depicted here. As you can see, there's a blue dot next to the trailers, which represents the weather telemetry system hub. And we have 2 wind speed and direction meters that we discussed in the case study, represented by the pink dots. The wind speed and direction meters were proposed to account for obstructions that might skew wind data at the telemetry hub near the trailers. So next slide, please. As I said, we have an example of when we may need to move our mobile perimeter air monitoring station on the eastern border. As you can see on the figure, our remediation area is a lot closer to that eastern border, and we move the monitoring stations closer together in attempts to reduce the likelihood that contaminant plumes will be missed by real-time monitoring equipment. And in this case, we would simply document on a printed figure where our stations were moved to during that portion of remediation. And that would be included in our final PAM report, which will be addressed later in this presentation. And if the predominant wind direction were coming from the southwest, say, then perhaps these stations would be more biased northward along that eastern boundary. And ultimately, the decisions of where to place the PAM stations can be made each day prior to the commencement of remedial work if you have an anticipated upwind-downwind direction. Next slide, please. Okay, so next we move on to identifying the schedule for monitoring. The previous slide showed where we anticipate to placing our real-time monitors, though those locations are subject to change depending on site work and wind direction. Our real-time monitoring is going to occur for the duration of the workday and will be powered on prior to work commencement and powered off after work has ceased. Upon startup, all real-time monitors are going to be zeroed and bump tested as applicable and field calibrated at designated frequencies as specified by user manuals. Each real-time station is going to have a PID to measure total VOCs, a desk meter to measure PM10, and a mercury meter, and will be connected to a telemetry system to relay real-time data to a computer system that will allow for immediate responses to exceedance conditions. All equipment will have data logging capabilities in the event that telemetry fails, and extra equipment will be stationed in trailers on chargers in the event that any field equipment malfunctions. Next slide, please. The next thing we are going to discuss are the locations and schedule for confirmatory sampling. The first thing we're going to do is conduct 3 consecutive days of confirmatory sampling prior to the commencement of any remedial activities. The pre-remediation confirmatory samples will be collected using the same methods selected for VOCs, metals, and SVOCs and mercury discussed in step 4. Then when we receive the results of the sampling, we will look at the analytical results to determine what sorts of compounds we are seeing in ambient air and their concentrations. And the ambient air results may help to make more informed decisions in the future if HBTVs for site COCs are being exceeded. Then we're going to conduct confirmatory sampling for all site-related COCs for the first 3 consecutive days of remediation at what we anticipate will be the prevailing downwind locations. If the HBTVs aren't being exceeded during the first 3 days of intrusive remediation, then we are going to use our professional judgment to reduce confirmatory sampling for all site COCs to once per week. And each day that we are conducting confirmatory sampling, all sampling methods discussed in step 4 will be deployed. Next slide, please. Continuing on from the previous slide, confirmatory samples are going to be placed at what we anticipate to be the prevailing downwind location for the day. The forecast for some days may show high variability in wind direction, and on those days we may elect to deploy multiple confirmatory samples and choose one set of samples to submit to the lab that best represent the predominant downwind location. Any field blanks, trip blanks, and field duplicates will be the same methods as detailed in step 4, but will be deployed at a frequency as specified in our site-specific quality assurance project plan. Next slide, please. Okay, so next we're talking about our shorter duration confirmatory samples that will be used at the site in cases where we have response level exceedances at the perimeter for greater than 45 minutes. Our shorter duration confirmatory samples will be collected for an hour at the location where the exceedance is being exhibited, and will be using the same methods as specified in step 4. The methods deployed will be specific to the type of exceedance that is being exhibited on the real-time monitoring equipment. So if the PID is alarming, we will be deploying all of our VOC methods. Additionally, when a PID is denoting an exceedance, a colorimetric gas tube sample will be collected to determine the presence or absence of TCE to aid in determining whether the alarm condition could be caused due to elevated TCE levels. And if the colorimetric gas tube indicates TCE is present during or after an alarm condition, then our soil disturbing work is going to be halted and we're going to amend our work practices. Next slide, please. If any of our HBTVs are exceeded during the first 3 days of remediation or during any regular confirmatory sampling, during our remediation project, these are the steps that we are going to follow to determine why an exceedance of the HBTV is occurring, and then potentially recalculate HBTVs with new data or establish new work practices to accommodate the information that we've received. First, we're going to review all of our analytical data we've received to see if there are any new contaminants in air that could be causing an exceedance issue. Then we're going to assess whether real-time monitoring instruments are not appropriate for monitoring at the perimeter given our site conditions. Then we're going to determine whether an incorrect surrogate was selected for the use of the perimeter or if the use of a surrogate in general is inappropriate. And lastly, we will review our characterization data to determine whether there's a chance that it is incomplete or if it's insufficient to calculate the HBTVs and response levels. Next slide, please. After we've completed step 5, we move to step 6, where we select the actions to address the exceedances to our perimeter response levels, which Erica discussed. If the 15-minute time-weighted response level is exceeded for greater than 15 minutes, the PAM technician is going to go check all of the equipment to make sure that it's functioning properly and identify any possible emission sources. If the exceedance continues for greater than 30 minutes, engineering controls will be instituted and attempts will be made to identify any additional remediation sources that hadn't already been identified. If the exceedance continues for a total of 45 minutes or more, engineering controls will continue to be instituted and a shorter duration confirmatory sample that we just discussed will be collected for an hour. And we're also going to collect a colorimetric gas tube sample, and that will be collected only if a PID is giving the alarm condition. If the exceedance extends into the 60-minute duration, we will continue to implement engineering controls, but work will be ceased to reevaluate work practices and emission sources. Next slide, please. And then finally, we move to step 7, where we discuss and document various aspects of the PAM plan, including modifications and review. Some modifications may not necessitate the revision of a PAM plan, which Erica already indicated. Those sorts of modifications could include relocation of perimeter air stations to accommodate varying wind conditions, or change in the selected methods used for real-time monitoring or confirmatory sampling. These sorts of modifications will be documented in our field notes and our daily summary logs, which will be included as part of the final PAM report. There are, however, some modifications that would necessitate a revision of the PAM plan because they have cascading effects. And this could include the change in selected remedial options, changes in exposure parameters like workday length or project duration, and that would require recalculating the HBTVs. And there's also the potential for the collection and inclusion of new characterization data that would require the revision of a PAM plan. Next slide, please. Lastly, when we are compiling our final PAM report for submission to the department as part of step 7, we are going to include at minimum the following information to demonstrate that our plan was protective of offsite receptors. And as we have reiterated throughout this training, documentation is going to occur throughout the entire PAM implementation. And it's going to be done in our field logbooks, it's going to be done in daily summary logs, and it's going to be done through laboratory deliverables and via our telemetry system. And our telemetry system is going to be conveying that real-time data from our real-time instruments. So all of this information is going to be tabulated and included in our final PAM report, and it's going to be submitted as part of the site's remedial action work plan. Next slide, please. Quickly, we're going over quality assurance. Our quality assurance and quality control relates to both our real-time instruments and our analytical sampling. Daily QA/QC testing is going to be conducted on all of our real-time instruments each day to allow for proper functioning. QA/QC testing on confirmatory analytical sampling media and instruments is going to be conducted at laboratories and the equipment providers supplying these supplies. As part of our daily QA/QC process, we are going to be documenting our work performed, the weather for the day, any perimeter exceedances, corrective actions, real-time monitoring issues, and information related to confirmatory sampling, such as locations, start and end times, and any QA/QC samples like field blanks, strip blanks, or any duplicates that we've collected. Next slide, please. Oh, and we have a poll question.
All right, we have our third poll question of the morning. But before we launch that, we just ask that you spell out acronyms when you ask questions, just because some of them we're not quite sure what they are, and it just makes it more clear for everyone. So if you could just spell those out in your questions, that would be great. Okay, so now the poll question: which modifications to a PAM plan should be documented? A, real-time monitoring location changes, B, change in remediation methods, C, change in work duration, or D, all of the above. So we'll give you about a minute to answer that, and make sure you are answering the polls so you can get your CECs. All right, we'll give you about 10 more seconds. Make sure you vote if you want CECs. You got to answer all the questions so we know you're here. You don't have to get it right, you just have to answer it. All right, and the answer is D, all of the above.
Thank you very much, Amanda. So up next, we are going to have Alan Matter going over the technical consultation process. Alan, you may start.
All right, thanks, Ryan. Next slide, please. I'm not going to reintroduce myself. I've been on twice. You should know who I am by now. Good news is this is a very short presentation, exactly 2 slides. So first thing I'd like to say is technical consultations are for site-specific issues that are very complex and related to that site. If you have issues that are related to the guidance document, or issues as to whether the applicability of the guidance document to your site, those should be given to the department contacts. Either call or email them. And the department contacts is listed here under the first 2 bullets are Erica Snyder and Amanda Gettelfinger, and their contact information is there. So again, if it's general questions about the guidance document or applicability issues, things of that nature, please don't request a technical consultation. Just contact Erica or Amanda and ask their questions. Next slide, please. Okay, so if you do have complex issues, if you do have complex issues, then a technical consultation may be warranted. Those should come to me, and they should be sent via email. The email should include an agenda identifying all issues at the time of the request. And the reason for this is that I need to identify all DEP personnel that needs to be present on the technical consultation. So if you just send me that you have some perimeter air monitoring stuff, I'll have Amanda or Erica attend, and then if you during the consultation bring up some administrative issues that should be handled by BIR or BRAP or something, those people would not be on the call. Make sure you identify all of the issues that you would like to discuss so we make sure we have appropriate personnel. Secondly, we request that you send PowerPoints, figures, tables, etc. that will be used during the technical consultation a week ahead. We don't always have time to review these in full, but it does help for us to look at them ahead of time. It saves a lot of time during the technical consultation with questions that we may have, things that would be coming up later in the consultation, or things that we may be able to look up ahead of time based on your PowerPoint. Third item I'd like to address is that you should request the technical consultation prior to the submittal of the document. So don't submit your document and then say, Oh, by the way, I'd like to have a technical consultation to discuss this. That's not the way it works. Have the technical consultation, make sure we all get on the same page. We can take that summary, put it into NGEMS, and then when your document is submitted, there's a record of what we discussed and what we had concurred with, and that'll help facilitate the review of the document. And then finally, technical consultations are not to be used for a notice of incomplete. Discussions with about notice of incomplete should be addressed through the chain of command, starting with the person who issued the notice of incomplete, then going to their supervisor, section chief, bureau chief, so forth. And if you don't get a resolution by that time, you can go to the technical review panel, which has been reinstituted, and they will be able to address your issue. Before I hand it back over to Ryan, I would just like to acknowledge a few people. When creating the calculator, I started off doing that because I find doing the programming and macros and everything very interesting. As my duties changed, I didn't have time to finish it up. And so Dana Galbraith, who's an absolute wizard with Excel and programming, stepped in and finished it. So I'd like to acknowledge her. Also, I'd like to acknowledge our moderators for yesterday and today. I think they did a fabulous job. And I'd like to acknowledge the entire CSRR training committee. They help us to polish our presentations. So they do a fabulous job and a lot of work behind the scenes. And then finally, Tyrone, Jordan, Anthony Teal, and the entire IT team who works behind the scenes to make all of this possible do a fabulous job. I'd like to thank them. And with that, back to Ryan.
Thank you for that, Alan. So we're going to enter our second questions portion of the day. So we will start with, if you have multiple soil samples, should you use the maximum concentration for the PAM analysis?
Okay, I think several times we have indicated that we're looking at a 95 UCL concentration for the area that's being remediated. So if you want to be very conservative, sure, use the maximum concentration, but what we're figuring is that during the course of the work, it's going to average out over what your average concentration is in the soil. So, you use your 95 UCL for that.
The total VOCs in Table 2 is for targeted VOCs only and not ticks, correct?
In this particular case, yes, that is right.
So the next question is, can you please go over how the summation of VOCs was calculated? Amanda, I think you said VOCs are detected above stringent standards are included. So for example, if you have arsenic less than 19 milligrams per kilograms, are they not included in the summation?
Arsenic would be one of our particulate bound species, so the VOCs wouldn't really apply here. The summation of the total VOCs in this case would be if you go through your characterization data, your RI data, and you find any concentration of any VOC exceeding its most stringent remediation standard. And then you put that, start an Excel table of anything that exceeds, and then you summarize for every contaminant that you have on your site. That would be your total VOCs for the property. Does anybody else want to speak to that?
No, I think that was good, Amanda.
So total VOCs at the site question. Does the calculation include the summation of all concentration of VOCs detected at the site, or is the summation only of VOCs that exceed the NJDEP standards at?
The summation would be for any concentration that exceeds the NJDEP standards.
So if a historic fill is assumed to be present but not characterized, how can one develop HPTVs?
Yeah, I think at that point, if you're going to be working in historic fill and that is your area of concern, then you're probably going to have to at least collect some samples in order to get an idea of what you have in the historic fill.
In lieu of air analytical confirmatory sampling for mercury, could you use a Luminex RA 915, which the EPA has determined that the sensitivity, accuracy, and precision ought to be equivalent to the laboratory analytical method?
I'm not familiar with that particular instrument, but again, if you have a contaminant-specific real-time monitoring instrument, you're comparing your data directly to the HBTV. So that is sufficient. However, as I said in the case with the field GC earlier, if you're having concentrations near your HBTV or exceeding your HBTV, you should be collecting confirmatory samples also. It's also recommended to collect them at the beginning of remedial activities like we state as well.
So the next question is, what is bump testing?
I'll touch on this, and then Bob, if you want, you can go a little further into bump testing, but it's a QA/QC procedure where you use a predetermined concentration of what we call a span gas, and you bring it to the interface of whatever monitor you're using to see if your monitor detects the concentration within a certain range of error. And Bob, if you want to add to that, please feel free.
Okay,
Yes.
good. Usually the bump testing procedure is set forth in the specific instruments documentation, manufacturer's instructions, and it typically is used, these instruments typically will have some sort of alarm setting for whatever criteria you're looking at in terms of ambient concentration. And the bump testing would be a gas that you know might exceed that alarm setting, so you can test the functionality of the instrument that you're using. And I don't know if there's anything more to add than that, but that's my understanding of how it works. It also verifies if you use an NIC traceable gas, in other words, of a known concentration, you can check whether or not the instrument is performing or recording a concentration within specifications.
So for the next question, we have, when we discuss exceedances of the 15-minute TWA, are these exceedances occurring consecutively or spread out across the day? So, for example, if you've reached your fourth exceedance in an hour, you would stop work. But what if the fourth exceedance happened at several points throughout the day? So one at 8 a.m., one at 10, 1 p.m., etc.
I missed part of that, but I'll do my best to address what I think the question was.
Yeah, so the first part of the question is, when we're discussing the exceedances of the 15-minute TWA, are these exceedances occurring consecutively or spread out across the day? The second half was just an example of what they were trying to explain.
Okay, so in this case, if it's suspected that these air emissions are associated with remedial activities, you should be following that same approach that I went over in step 6. But if they can be attributed to meteorological conditions or an off-site source, well, then that would play into your decision making.
Yeah, the example I think that Erica was giving in her talk, though, they were consecutive exceedances. So you were going from 15-minute exceedance to 30-minute to 45-minute to 60-minute exceedance. If you have an exceedance and then you have an hour of no exceedance and then another 15-minute exceedance, I think that would restart your process of the actions you're going to be taking. Also, I'd just like to really quickly clarify the question about historic fill. If all you're doing is capping historic fill, there's probably no need to do the perimeter air monitoring because you're not really disturbing the soil or having anything come up. The reason I said about collecting samples, if you're going to be doing activities that is going to potentially be causing emissions and the activities that you're using would fall within the range that we provided earlier for applicability, which would be 20 days to 225 days. That's when you would collect samples. If you're just capping the historic fill, I don't see a need to do that.
And if I can just add to the actions to address exceedances, another thing to consider, it's really going to be a site-specific determination, but if your response level exceedances are high, like much greater than your response level, then I do think you should take a conservative approach because your HBTV is based on the workday duration. So whether it's 4 right together or 4 spread across the workday, it's still in reality going to be compared to that HBTV that's averaged across the workday. So if you have elevated concentrations, you should be more conservative in your approach.
Is perimeter air monitoring required for historic fill sites during normal construction activities? If so, if the worksheet defaults to the PM10 limits, is just dust monitoring okay? Is analytical sampling required?
Okay, I think that's probably a follow-up to the other question, which is why I did the clarification that I just gave. So, again, if you're just capping historic fill, it's completely different than if you're excavating and moving it. So, if you're going to be doing a lot of work with historic fill, that's going to trigger the PAM requirements, and you're going to be moving the historic fill around and so on and so forth, then you should probably take a few samples. And again, it doesn't have to be a plethora of samples, just enough to understand what you have out there in order to determine whether the NACs would be sufficient or whether you have something that would trigger a more stringent monitoring. Typically with historic fill, you won't see volatiles, so it really should just be particulates that you're looking at.
Can we use real-time site contribution calculations, DW-UW, to compare against the response levels? This could use the wind direction each minute to assume monitors as UW or DW, similar to the SCA QMD Rule 1466.
So I think you're talking about crosswind and downwind.
Yeah, upwind, downwind.
Yeah, I realized midway through the question, downwind and upwind.
From what I understand, can you use instantaneous readings to evaluate whether or not you got a response level exceedance issue? Is that really what they're talking to? If that is the case, one of the things you could do is that if you have like you say, if you have a gross exceedance of the response level, number one, okay, and that might be enough to raise the alarm to do something, to see what's going on, to see if you have a hotspot situation. But if you have a series of spikes that are above the response level, but not that much, and they occur periodically, like every 1 or 2 minutes, the whole purpose of taking a 15-minute average is to get a mean concentration over that period, so you can really truly evaluate whether or not your response level is going to be exceeded. I don't know if that answers your question, but I'm trying to understand what they're getting at.
Ryan, I was actually hoping you could reread that question for better retention.
Yes, give me 1 second. So can we use real-time site contribution calculations to compare against the response levels? This can use the wind direction each minute to assign monitors such as upwind or downwind.
Yeah, I assume if you have the software to be able to do that and the wind direction is sufficiently reliable or consistent from a given direction, I mean, there's no reason you can't do that. I mean, it would take it would sounds pretty tedious to me, to be honest. But if you have a situation where you're looking at the downwind concentration and you're subtracting the upwind concentration just to look at the attribution, I suppose that's an approach that can be used. I mean, that type of approach has been used using more representative techniques, path average concentrations and things of that nature. But I don't see a big problem with that. I don't know if anyone else can speak to that.
Yeah, I'm also not sure if they were asking, like, if you have variable wind, if you can assign different stations as upwind and downwind. And I would say yes, probably you wouldn't want to do it on a minute by minute basis. You'd probably want to do it a little bit longer time frames. But yes, if wind direction is changing, then your stations that you had originally designated as downwind may no longer be downwind.
If metals and/or BNs are your only chemicals of concern, could you evaluate these contaminants via real-time monitoring and not collect confirmatory samples?
I think Alan addressed that already. I think if you have just metals and base neutrals, ultimately, it's going to be based on your site conditions, surrounding receptors, things like that. It's hard to answer that question generally.
Yeah, I would just say that generally you're going to have pretty, the higher the concentration of contaminant in the soil, the lower the amount of particulates you could have. So if you had 100% lead, then your concentration of particulates is going to be pretty low. But typically for concentrations that we would see, I'd say that the NACS of 150 is probably going to be the controlling level, but what you would have to do is make that determination on a site-specific basis. So you'd have to have some data to base that on, and if everything is controlled by the NACS, then probably just doing dust monitoring would probably be sufficient. I don't know, Bob, do you want to weigh in on that?
I would think you're correct. I tend to agree with that. That the dust that should be sufficient. I mean, if you could repeat the question, I kind of forgot what it was. If you can just repeat it real quick.
If metals and/or base neutrals are your only chemicals of concern, could you evaluate these contaminants via real-time monitoring and not collect confirmatory samples?
I think you really always want to collect some confirmatory samples because you want to really confirm exactly. You're not certain as to what the concentrations really are. You really want to evaluate that so that you don't have any. I guess your work is based on the initial characterization of the site, so you want to make sure that's pretty much what the assumption is and what's being maintained.
Yeah, if you don't have confirmatory data confirmatory contaminant specific, I should say, data to compare against, you're really not going to be sure. So you do need to have some contaminant specific data.
Is there a reporting requirement for confirmatory sampling completed, for example, included in the remedial investigation or remedial action report?
I think that's speaking to laboratory results from confirmatory sampling, and yes, that would need to be included in the final PAM report as part of your RAR.
Why the requirement to elevate for any NJDEP soil standard and not specific to the inhalation soil standard?
See, try not to get confused between the different pathways. If you're remediating for a contaminant, even if it's based on the ingestion dermal pathway, doesn't mean it won't be a concern when it's in the air. So you need to look at the whatever you are remediating for, whatever contaminants are there, regardless of the pathway, the exposure pathway for the remediation standards, you need to evaluate them for the perimeter error monitoring. There are two very separate things. The inhalation exposure pathway has very different parameters that the soil standards are based on, and those are soil standards. Once that stuff is in the air due to a remediation, it's a completely different situation, and now we're looking at the concentrations in an air being inhaled due to active remediation. So the scenarios are completely different.
So I believe we have time for one more question. Does the PAM plan apply to building demolitions or just soil disturbances?
So the PAM plan is going to apply to sites that fall under the contaminated site remediation program. There are, I don't know it off the top of my head, I know that there are national emission standards that address demolition of buildings, but it's the remediation of contaminated sites that's going to fall under the purview of this guidance document.
All right, thank you for answering all those questions. We have more that haven't been asked out loud, but we are out of time. So just a reminder, if we didn't get to your question during today's training, you will hear from us in the next several weeks. The committee will go through and answer those questions and make sure you get those responses. Just a few reminders before we conclude today. Like I said, the questions not answered will be answered via email. We ask that you fill out the course evaluation on SurveyMonkey. That was also dropped in the chat for you to click on. The feedback really helps us improve our trainings. Look out for an email from the LSRPA for CEC certificate access. And slides and presentation will be posted on our training page probably within the next few weeks. So you can always go back to look at the recording and look at the slides. I hope everyone has a great day, and thank you so much for coming.
Thank you, everybody. Have a good day.